Again, if you want to work on these problems before you watch the videos and then check your answers, that would be totally fine. You only have to watch videos if you got one wrong. Or you can just watch videos all the way through. That's fine too. So a card is drawn at random from a deck of cards. There are 52 cards in a deck. We want to know the probability of getting a club or a diamond. Clubs and diamonds, those are two totally different things. This is a mutually exclusive. Mutually exclusive, there is no overlap. You can't have a card that's a club and a diamond. So all we need to do is the probability of getting a club, plus the probability of getting a diamond. So out of our 52 cards, a fourth of them, 13 of them, are clubs, and out of our 52 cards, 13 of them are diamonds. So we add those two together. We get 26 out of 52, which is 1/2, which is 50%, of course. If you don't know if you're not very familiar with decks of cards, just Google what a deck of cards is so you can get this information, because I know not everybody's familiar with cards. That's okay. All right, we want to know the probability of getting an ace or a spade. So we want to know, is there overlap? Is it possible to have a card that is an ace and a spade? And the answer is yes, there is overlap. So this is an inclusive event. So when we do the probability here, we need to do the probability of getting an ace plus the probability of getting a spade, and we need to subtract the overlap, probability of having both. So the probability of getting an ace, out of those 52 cards, there's 4 aces. Probability of getting a spade, out of the 52 cards, there's 13 spades. And our overlap, a card that is both the ace and a spade, well, it's the ace of spades, there's only one of those. So one card falls into both of those categories. So we have to subtract it out so we don't double count. So that's 17 minus 1 is 16 out of 52. That probably reduces to 4/13. I totally ran out of space. 31%, I think. All right. We have the probability of getting a jack or a red card. So we need to think about, is there overlap between those? Can you have a card that's jack and red? The answer is you definitely can. This is an inclusive event. There's overlap. So we need to do the probability of jack plus the probability of red minus the probability of both. So in our deck of cards, out of our 52, there are 4 jacks. Out of our 52 cards, half of them are red, so that's 26. And then our overlap. Jacks that are red, there's 2 of them. There's a jack of hearts and a jack of diamonds, so our overlap is going to be 2. So we have 4 plus 26, that's 30 minus 2, which is 28 out of 52. That probably reduces, how about 7/13? And as a percent, 54%. I don't have room for that in here. All right, so let's move on to the next problem. We have a French class. There are 10 freshmen, 1 boy, 9 girls, 8 sophomores, 6 boys and 2 girls, and 2 juniors, 1 boy and a girl. We want to know what's the probability if we randomly pick a student that we get a freshman or a female. So we need to ask, is there overlap? Can you be freshman and female in this class? And the answer is yes. This is inclusive. So we need to subtract our overlap. So probability that you're a freshman plus the probability that you're female minus our overlap that you're both. Okay, so the probability of freshmen, let's see, there's 20 people in this class. 10 freshmen out of 20 plus females. Let's see, we've got 9, 10, 11, 12 females. And then we have to subtract the overlap that are both freshmen and female. There's 9 of those. So we get 22 minus 9, so 11, sorry. No, is that right? freshman and female, you have 22 minus 9. 13. 13/20, let's see, as a fraction, or as a percent, that's going to be times 5. 65%. Can I get that in there? Okay, next one. We want to know the probability of a sophomore or a male. So again, do we have overlap? Is it possible to be sophomore and male? The answer is yes. This is another inclusive event. So first we want the probability of being a sophomore. So out of our 20, we have 8 sophomores. Plus the probability of being male. Out of our 20, we have 1, 7, 8 boys. And then we have to subtract our overlap. Sophomore males, there were 6 of those. Oops, that goes over here. So we end up with 16 minus 6, so 10/20. So 1/2, which of course is 50%. All right, last one, number 3. We want to know the probability of being a freshman or a sophomore. So again, ask yourself, is there overlap? Can you be a freshman and sophomore at the same time? The answer is no. So this is a mutually exclusive event. So all we need to find is the probability of being a freshman. So 10 freshmen plus the probability of being a sophomore. And there are 8 sophomores. So we have 18/20, which reduces to 9/10 or 90%. All right, so last one, we are almost done. A survey found that the probability of a student driving while texting was 0.16, the probability of a student getting into an accident while driving was 0.07, and the probability of a student getting into an accident while driving and texting was 0.05. And what is the probability of a student driving while texting or getting into an accident while driving? Let me write that down. We want to know the probability of a student texting while they drive or getting into an accident. Okay, that's what we're asked to find. We need to decide if there's overlap. Is it possible to get in an accident while you're texting? And the answer is yes, so we have data on that. So this is an inclusive event. So we need to find the probability of texting plus the probability of getting an accident, and then we need to subtract the probability of both of those things happening. Okay, our probability of texting while driving, just texting while driving, is 0.16. Probability of getting into an accident is 0.07. And the probability of both of them happening was 0.05. So all we have to do is add those up. 0.16 plus 0.07 minus 0.05 is 0.18, or 18%.